The script runs fine for a few minutes, then the connection dies, the IP changes, or everything just hangs. This is the single most common message I get, and almost every time it comes down to one of about 8 causes. In this video, I am going to name all of them and show you the fix for each so you can stop guessing and actually diagnose what is happening.
We are hardware proxy farm in Singapore, real phones, real SIM cards from Singtel M1 and StarHub on the live carrier network. So when a connection drops, I can usually tell from the symptom alone whether it is the carrier, the provider, your client code, or the site you are hitting. Let us go through the causes in the order I check them.
Before anything else, you need to answer one question because it splits the whole problem in half. Is the IP changing or is the connection actually dropping? These feel the same from the outside, but they are completely different problems. Log the proxy IP on every single request. If the IP address changes but your requests keep succeeding, that is rotation, and it is usually normal and fine. If the connection times out, refuses, or hangs, that is a real disconnect. Most people never make this distinction, so they try to fix a disconnect when what they actually have is rotation they should have designed around. Figure out which one you have first, because one is the most common, and it is not really a fault at all. Mobile IPs rotate on the carrier schedule. Every mobile carrier puts its devices behind carrier-grade NAT, and the public IP assigned to a SIM changes periodically as a normal part of how the network manages addresses. This is not your proxy breaking. It is the carrier doing exactly what it does for every real phone in Singapore. The fix is not to stop the rotation, it is to connect through a stable gateway endpoint that stays constant while the IP behind it changes. A good provider gives you one hostname and port that never moves, and the rotation happens invisibly behind it. If your code talks to the gateway instead of a raw IP, a carrier rotation does not break your session at all. Cause 2 is rotation set too aggressively on purpose. A lot of providers and a lot of users set the IP to rotate every 30 or 60 seconds. For a single quick request, that is fine. For a login, a checkout, or any multi-step flow, it is fatal because the IP changes halfway through and the site sees a session that teleported to a new address. The fix is a sticky session with a duration long enough to finish your task. Set the sticky time to cover your whole flow, a few minutes at least, and rotate only when you choose to, not on a timer that fires mid-transactions. Host 3 is the SIM re-registering with the tower. This is a real brief disconnect and it is physical. When a phone hands off between cells, or the signal dips, or the tower drops and reacquires the radio, the data connection blinks for a second or two. On a real mobile network, this happens occasionally and it is unavoidable because it is a real radio on a real tower. The fix is on the client side. Your code needs to retry once on a dropped connection instead of crashing. One automatic retry with a short wait absorbs almost every tower blip. If a single dropped request kills your whole run, the problem is that your code assumed a perfect connection, which no real mobile connection ever is. Cause 4 is too many concurrent connections to one device. A single mobile proxy is one phone with one radio. If you fire 40 parallel threads through it, you are asking one handset to behave like a server, and it will start refusing or dropping connections. This looks exactly like an unstable proxy when it is actually you overloading one device. The fix is to cap your concurrency per IP. For a single mobile proxy, keep it to a handful of parallel connections, not dozens. If you need more throughput, you need more devices, not more threads through one. Cause 5 is a protocol and keep alive mismatch. Mobile connections have higher latency than data center connections, anywhere from 80 to 350 milliseconds, and they need their connections kept alive deliberately. If you are using SOX 5, use SOX 5H so DNS resolves through the proxy and not your local machine, which prevents a whole class of stalls. Set the TCP keep alive so idle connections do not get silently reaped. And give your requests a real timeout, 15 to 30 seconds, not the 3-second timeout that works on a data center proxy. A lot of disconnects are just a client timeout firing too early on a connection that was about to respond. Cause 6 is carrier-grade NAT idle timeout. And this one catches people who hold connections open and quiet. Carrier net tables drop entries that go idle. If you open a connection, sit silent for a couple of minutes, then try to use it again, it may already be gone on the carrier side and you see a dead socket. The fix is a heartbeat. Send a small keep alive request every 30 to 60 seconds on a long-lived connection so the net entry stays warm. This is the cause behind a lot of disconnects that only happen after a pause in activity. Cause 7 is the one people never suspect. The target site is dropping you, not the proxy. When you scrape too fast or trip a bot detection rule, many sites do not return a clean error. They just drop the connection, reset it, or let it hang until it times out. From your side, that looks identical to a flaky proxy, so you blame the proxy and switch providers, and the new one does the same thing because the proxy was never the problem. The fix is to slow down, add realistic delays between requests, and rotate to a fresh IP when you actually get blocked, not on a blind timer. If the disconnects only happen on one specific site and never on a neutral test like ipinfo.io, the site is dropping you, not the proxy. Cause 8 is the provider itself, an oversubscribed shared pool or a mid-session bandwidth throttle. On a cheap shared plan, one IP is shared across many users, and when the device gets overloaded or another user on it gets the device throttled, your connection suffers for reasons you cannot see or control. Some providers also throttle or cut your session quietly once you cross a bandwidth threshold they do not advertise. The fix here is structural. A dedicated device that nobody else is touching, and a plan where you know exactly what happens at the cap. If the disconnects are random, frequent, and you have ruled out the other 7 causes, the provider is the cause. So here is how I actually diagnose a disconnecting proxy, in order. First, log the IP on every request and decide is it rotation or a real drop. If the IP changes but requests succeed, switch to a stable gateway endpoint and a sticky session and you are done. Second, if it is a real drop, test against a neutral endpoint like ipinfo.io in a tight loop. If that is stable but your target keeps dropping, the target is blocking you, so slow down and back off. Third, check your concurrency. Pull it down to a few threads per IP and see if the drops stop. Fourth, fix your client SOX5H TCP keep alive, a 30-second timeout, 1 automatic retry, and a heartbeat on idle connections. Fifth, only after all of that, if it is still dropping on a neutral endpoint at low concurrency with a clean client, the provider or the plan is the problem and you move to a dedicated device. Let me give you the client-side settings that fix most of this because they are the cheapest thing to change. Use SOX5H, not SOX5, so DNS goes through the tunnel. Set your request timeout to 30 seconds to give the mobile latency room to breathe. Enable TCP keep alive. Wrap each request in a single retry with a 2-second wait so a tower blip costs you a retry instead of a crash. Keep concurrency low per IP. And on any connection you hold open, send a tiny heartbeat request every 30 to 60 seconds. Those 6 settings alone clear up the large majority of the disconnect reports I see before you change anything about the proxy at all. A word on what is normal, because not every change is a problem to fix. A mobile IP that rotates is healthy. That is the entire reason mobile proxies work. The address keeps moving the way real subscriber traffic does, and a small amount of rotation and the occasional 1-second tower blip are signs you are on a real carrier network, not a static data center IP pretending to be mobile. The goal is not zero rotation. The goal is a connection that survives rotation cleanly with a stable endpoint in front of it and a client that retries a blip instead of dying on it. Fight the real disconnects and design around the normal ones. The honest caveat is that the right fix depends on which cause you have, which is why the diagnosis order matters more than any single setting. If you skip straight to blaming the provider and switch services, but your real problem was 40 threads through one device or a 3-second timeout, you will see the exact same disconnects on the new provider and conclude that all mobile proxies are unreliable. They are not. They are real radios on real towers and they behave like it. Once your client is built for that, A good mobile proxy on a dedicated device is stable enough to run multi-step flows and long jobs without babysitting. If you have run through all 8 courses and a dedicated device on a real Singapore carrier still drops on a neutral endpoint at low concurrency with a clean client, then send your provider the specifics: the endpoint, the concurrency, the timeout, and the exact symptom. A real operator can read those numbers and tell you in one reply whether it is the carrier, the device, or something on their side. Vague reports get vague answers, precise ones get fixed.